February 12, 1943. Above the broken clouds of northern France, the sky lay hard and colorless, a pale plate of winter light. The Typhoon's cockpit vibrated as Flight Lieutenant Roland Beaumont eased the throttle forward, the Napier saber roaring into a higher pitch. The altimeter read 22,000 feet. His oxygen mask hissed with each breath. Below, the fields around folded into a gray quilt of frost and hedgerows. To the west, contrails scratched thin lines toward the channel. Two Focke-Wulf 190s had turned inside his formation minutes before, slicing through at impossible angles. Beaumont rolled the Typhoon to starboard, following the instinct that all pursuit pilots develop, the small pull in the gut that says now. The control column pressed back against his gloves, heavy but obedient. At 400 miles per hour, most fighters stiffen like frozen metal. The Typhoon did not. The spring tabs in its wings gave just enough leverage to keep the ailerons alive. His wingman, Pilot Officer Jock Fraser, came across the radio, "They're diving, Roland." Flat out. Beaumont saw them, dark specks streaking toward the low haze. He followed, nose down, the speed climbing past 420. The sound shifted from a growl to a rising howl as air friction clawed at the fuselage. At that speed, every control movement mattered. The FW-190s began to twitch and waver. Their wingtips shuddered. One tried to roll away but froze mid-bank. The Typhoon rolled cleanly, effortlessly, the spring tabs doing their quiet work. Beaumont could feel the mechanism through the stick, a faint, springy resistance, as if the aircraft anticipated his intent. Below him, the German pilots fought physics itself. The FW-190's control surfaces, unassisted and thickly hinged, locked under the crush of airflow. At 400 miles per hour, their ailerons may as well have been welded. Fraser's voice again, more clipped, "They've gone stiff." Beaumont didn't answer. He was already pulling out, the horizon swinging level as the altimeter needle steadied. Behind him, one of the Focke-Wulfs overshot the dive and vanished into the low overcast, unable to pull up in time. Another clawed out laterally, banking too late to fire. In that brief sequence, 10 seconds of descent, the advantage of the Typhoon's new control system had been proven not on a drawing board, but in air thick with the sound of death. Before we jump back in, tell us where you're tuning in from, and if this story touches you, make sure you're subscribed, because tomorrow, I've saved something extra special for you. Later, in his combat report filed at RAF Manston, Beaumont wrote only a single line about the engagement: German pursuit failed due to control stiffness beyond 400 miles per hour. Typhoon maintained maneuverability. The mechanics on the ground didn't see the philosophical weight of that sentence. But in the air war of 1943, it marked a divide. The Luftwaffe still relied on the strength of its pilots, the trained instinct, the hard muscle behind the stick. The RAF, by contrast, was learning to let engineering shoulder the burden. Above Cannes that morning, the clouds began to close again, blurring the horizon into a dirty smear. The Typhoons reformed, for shapes in loose echelon, the engines thundering in perfect synchrony. Beaumont glanced at his fuel gauge, then at the sun's pale edge sinking westward. "Back across, lads," he said quietly into the intercom. "We've made our point." They turned toward England, leaving the shattered air behind them. Behind their retreating formation, a lone FW-190 limped homeward. Its pilot, Oberleutnant Karl Boris of JG-26, would later tell his ground crew the same story from the other side. "I could not roll," he said. At 650 kilometers per hour, the controls became stone. The Englishman rolled like he was still on the ground. Two nations, two aircraft, one truth at 400 miles per hour. In the cold air over France, the laws of aerodynamics had chosen sides, and the Typhoon had learned how to bend them. Long before the Typhoon screamed over France, its story began in quiet rooms filled with draftsmen in doubt. In 1941, at the Hawker factory in Kingston, engineers huddled over blueprints that no longer looked like airplanes, they looked like arguments. The war demanded speed, altitude, and firepower in combinations that strained both metal and men. The Hurricane, once Britain's sword, was already an anachronism. Hawker's chief designer, Sir Sidney Cam, sketched what he hoped would replace it, a machine that could dive faster than any German fighter and survive it. But speed came with invisible chains. As aircraft broke past 350 miles per hour, control surfaces stiffened under aerodynamic load. Air, once the pilot's ally, turned to concrete. Engineers called it compressibility, though the name understated its cruelty. It was not compression of air, but of control, pressure that multiplied across the ailerons and elevators until a man's arms were no longer enough. Flight test reports from Boscombe Down, dated December 1941, warned bluntly, stick forces become intolerable above 380 miles per hour. Control reversal imminent. At such speeds, even minor maneuvers could rip the wings from their mounts. The Typhoon's thick wing, designed for stability, worsened the effect. Enter Leslie Frise, a quiet innovator from Bristol who had been experimenting with an idea almost heretical in pre-war Britain, the spring tab. It was a small auxiliary surface attached to the trailing edge of a control surface, moving in the opposite direction of the main deflection. When the pilot moved the stick, the tab counteracted aerodynamic pressure, effectively helping him move the larger surface. The result was leverage, mechanical advantage without hydraulic power. Frise's idea had lain dormant through the 1930s, dismissed as too complex. But in 1942, the Typhoon's growing pains gave it urgency. Reports from RAE Farnborough noted test pilots returning with forearms numb from effort. One line in the minutes of the Hawker design meeting of April 17, 1942, captured the turning point. A method of restoring control authority at high speed must be found, or the aircraft's future is in question. The German approach, meanwhile, remained rooted in human endurance. Focke-Wulf engineers at Bremen, working on the FW-190A series, prioritized aerodynamic balance, mass balances on control surfaces, careful hinge geometry, but avoided any mechanical assistance. The Reichsluftfahrtministerium, RLM, viewed such devices as pilot crutches. German pilots were trained to respect stiffness as a mark of speed and control, not as a failure of design. When Hawker tested the first springtab-equipped Typhoon in late 1942, the difference was immediate. Wing Commander Martindale, in RAE Test Flight 43/12, recorded aileron movement at 400 miles per hour possible with one hand. Response remains linear. What had been brute labor became finesse. The engineering notes read like revelations disguised as numbers: control force reduction, 60% at 400 miles per hour. Roll rate, increased from 60 degrees per second to 85 degrees per second. Pilot fatigue, negligible at sustained high-speed turns. In the war's arithmetic, those figures translated to survival. Back in Germany, the Focke-Wulf test department logged opposite results. The FW-190's roll rate, once legendary at low speed, degraded sharply above 650 km per hour. In a 1943 report later captured by Allied intelligence, test pilot Hans Sander wrote, "Beyond 700 km per hour, full lateral control no longer available." Recovery from dive dependent on pilot strength. The divergence between the two nations had begun not in battle, but in belief. The British assumed machinery should compensate for human limits. The Germans assumed men should overcome them. By winter 1943, the spring tab had moved from prototype to production. Typhoons rolling out of Gloucester and Langley carried the quiet innovation hidden inside their wings. Pilots never saw it, but they felt it every time the stick moved smoothly where it once fought back. In an RAE summary memo dated January 1943, a line was underlined twice in pencil: "A pilot cannot fight air pressure, he must persuade it." That persuasion would soon unfold not in the lab, but in the sky over northern France, where Luftwaffe pilots strained against frozen sticks while Typhoons rolled effortlessly through the air. At 400 miles an hour, physics would decide which philosophy survived. By the spring of 1943, the skies above northern France had hardened into an invisible front. Each morning, Typhoons from No. 609 Squadron RAF roared across the channel in pairs and fours, their undersides painted black and white to avoid friendly fire. Their task was simple on paper: intercept trains, sweep roads, and lure the Luftwaffe into combat. In practice, it was a duel of machines as much as men. Opposing them were the veterans of Jagdgeschwader II Richthofen and JG-26 Schlaggeter, flying Focke-Wulf 190 A4s and A5s, sleek, rugged fighters built for agility and sudden violence. Early encounters had favored the Germans. Their FW-190s could outclimb and outturn almost anything below 20,000 feet. But by March 1943, something in the pattern began to change. German after-action reports, once confident, began to include new and troubling phrases: Kontrollkraft zu groß, control forces too great. The trouble revealed itself in the dives. On March 28, 1943, near Le Treport, a pair of Typhoons from 609 Squadron engaged 4 FW-190s. Witnesses on both sides would later describe the same scene: the British fighters plunging into a steep, shrieking descent, the Germans following, then faltering. At about 400 miles per hour, the Focke-Wulfs stopped rolling. Their control columns froze against the airflow. One pilot, Lieutenant Heinrich Rossbach, later told interrogators after his capture, "It felt as though the wings had turned to iron. You could not move them. The Englishmen rolled while we slid." The contrast was mechanical, not mystical. The Typhoon's spring-tab ailerons, fitted to production models beginning that February, gave its pilots control authority even under crushing air pressure. When Beaumont or Fraser rolled at 400 miles per hour, they did not fight the air, they guided it. The FW-190 pilots, lacking that mechanical aid, faced aerodynamic lock. An RAF engineering officer at Manston put it more bluntly: "Their stick is a crowbar. Ours is a lever." That spring, Luftwaffe maintenance crews at Abbeville began filing reports of overstressed wings and damaged control linkages. German flight logs recorded repeated warnings: avoid dives exceeding 700 km per hour, controls inoperative. Yet the nature of combat, sudden dives to escape, desperate rolls to evade cannon fire, made those speeds unavoidable. From the British side, the difference was visible through the gun camera. The National Archives preserve a frame-by-frame sequence from April 10, 1943, a Typhoon diving on 2 Focke-Wulfs. At frame 127, the German aircraft banks left and begins to roll. By frame 133, the roll stops mid-motion, the plane half-inverted, frozen in a fatal pose, while the Typhoon completes its arc and opens fire. Back at RAE Farnborough, analysts studied the recovered film and combat reports. Their conclusion echoed across engineering circles: roll stiffness in enemy aircraft appears critical beyond 380 miles per hour. Typhoon unaffected. The Luftwaffe tried to compensate through tactics rather than technology. Formation leaders ordered shallower dives and emphasized vertical separation. But physics allowed no negotiation. In a fight decided by altitude and airspeed, the one who could still steer at 400 miles per hour held command of the moment. During debriefings, RAF pilots often mentioned the peculiar serenity of those engagements. Flight Lieutenant Beaumont would recall, "You could feel the German struggling. He would begin a roll, stall halfway through, then vanish into cloud." The Typhoon stayed light, almost calm. It was not calm for the men in those freezing cockpits. German pilots returned to base with bruised shoulders and swollen wrists from straining against the controls. Some developed chronic tendon injuries, an invisible echo of aerodynamic defeat. By June 1943, intelligence officers of 12 fighter commands circulated a classified summary titled Enemy Control Limitation Report. One paragraph stood out: "Our pilots report enemy fighters unable to maneuver effectively in dives exceeding 400 miles per hour. It is probable that Allied aircraft equipped with assisted control surfaces possess decisive advantage." That line would soon find its proof in the wreckage scattered across the French countryside. The Luftwaffe's finest machines were reaching the limits of muscle and metal alike. The Typhoon, born in crisis, had found its strength not in power, but in mechanical empathy, a design that turned human weakness into precision. Over France, the lesson was written in contrails: one side fighting the wind, the other riding it. The Typhoon's triumph in the air masked a tortured birth on the ground. In 1940, the project had come close to cancellation. Its designer, Sir Sidney Cam, had promised the Air Ministry a new generation of fighter capable of 400 miles per hour and armed with 420mm Hispano cannon. The result, however, was an aircraft that could barely stay intact. Early production Typhoons were plagued by tail failures. At RAF Gloucester, 2 aircraft disintegrated in flight during dives. Investigators found that turbulent airflow from the thick wing struck the tailplane with punishing resonance, snapping the rear fuselage clean off. Flight tests were suspended. The press called the Typhoon Cam's catastrophe. Within Hawker's offices, engineers stared at piles of wreckage and wondered if they had pushed aerodynamics past the point of reason. Cam refused to abandon the design. "If we stop now," he told his team, "we will have built a monument to hesitation." The challenge, he realized, was not just strength but control. Pilots could not steer the aircraft at the speeds it was meant to fly. Even if the tail held, the stick forces at high speed made precision impossible. That problem fell to Leslie Frise, the soft-spoken aerodynamicist whose name would later become synonymous with mechanical empathy. Frise had spent years studying control loads at Bristol Aeroplane Company before joining the wartime effort. He knew that airflow over an aileron generated enormous hinge moments. The faster the flight, the harder the pilot had to fight. His solution was almost deceptively simple: a spring tab. It looked like a small flap attached to the trailing edge of the aileron, hinged to move opposite the main surface. When the pilot moved the stick, the tab deflected slightly, using aerodynamic force to assist the larger motion. It turned air pressure, the enemy, into an ally. In July 1942, the first Typhoon with experimental spring tabs flew out of Boscombe Down. Test pilot Philip Lucas described the difference in his logbook: controls remained positive and light at 400 miles per hour. Effort reduced to 1/3 previous levels. It was the sort of note engineers dream of seeing. Farnborough's RAE Technical Memorandum Aero/2327 soon followed, documenting a 60% reduction in roll forces. The Typhoon, once brutal to handle, had become supple. Meanwhile, the Luftwaffe's Focke-Wulf engineers faced the same physics and refused the same solution. Their aircraft remained masterpieces of craftsmanship, but they clung to manual purity. The notion of power-assisted controls was seen as undermining the pilot's discipline. "The machine must never command the man," wrote one RLM inspector in 1943. But the air itself was beginning to command both. The British were less romantic. Hawker mechanics installed the new tabs on every Typhoon that came through Gloucester by the end of that year. They did it quietly, without press releases or ceremony. The pilots noticed immediately. "Before, you wrestled it," recalled Flight Lieutenant Johnny Baldwin. "After, you guided it." Engineering reports tell the same story in cooler language. A factory memorandum dated November 22, 1942, lists 3 sequential modifications: reinforcement of rear fuselage structure, revised elevator horn balance, introduction of spring-tab ailerons per RAE design. Each change addressed a failure. Together, they forged redemption. By early 1943, when the first combat-modified Typhoons crossed the Channel, they carried not just bombs and cannon but the distilled product of every engineer's sleepless night. The machine that had once killed its test pilots now rolled faster, climbed steadier, and returned home intact. Cam visited the assembly floor in January 1943. Workers paused as he walked among the half-finished fuselages, their aluminum skins gleaming under factory lamps. "We built the strength," he said, but Frise gave it the touch. The RAF's technical journal that spring included a brief notice easily overlooked among reports on radar and engines: spring-balanced control tabs fitted to Typhoon production series with favorable results. No photograph accompanied it. No fanfare. Yet that quiet line marked the moment British engineering transcended brute force and entered the realm of feel. When the Typhoon next met the Luftwaffe over France, the battle of strength versus subtlety would be settled not by horsepower or firepower, but by the gentle flex of a spring hidden beneath a wing. Preparing and narrating this story took us a lot of time, so if you are enjoying it, like this video, It means a lot to us. Now back to the story. July 30th, 1943. The morning over the channel lay still, the air heavy with the kind of haze that flattened distance. From the dispersal field at RAF Manston, 12 Typhoons of No. 609 Squadron lifted into the light. Their target, the Abbeville rail yards, vital arteries feeding German armor to the Normandy coast. The mission order bore a simple label, Ramrod 90. Flight Lieutenant Roland Beaumont, leading the formation, had flown dozens of sweeps across France, but today's mission carried a sense of trial. Intelligence had warned of increased Luftwaffe presence, elements of JG-26 Schlagiter regrouping under Adolphe Galland's directive to defend northern France to the last liter of fuel. By 09:20 hours, the Typhoons crossed the French coast near Le Touquet, the sabres droning low over the dunes. The attack run was swift, 2 passes over the marshalling yards, rockets and cannon fire tearing through boxcars and locomotives. But as the British fighters turned north to regroup, contrails appeared above them, Focke-Wulf 190A5S diving from altitude. Beaumont saw them at once, 8 aircraft, sun behind, closing fast. He broke formation and called over the radio, "Bandits high. Take them as they come." The Typhoons rolled inverted and dove to meet the threat head-on. The first pass blurred into chaos. Cannon shells stitched the sky, one Typhoon vanished into a plume of black smoke. At 15,000 feet, the formations fractured into pairs and singles. The German pilots, skilled and fearless, tried to force the fight downward, using gravity to build speed. But as their aircraft plunged past 400 miles per hour, the same old demon appeared, control stiffness. RAF gun camera footage later recovered from Beaumont's aircraft tells the story in silent detail. Frame 42 shows a Typhoon braking left, the horizon rotating cleanly beneath it. Frame 46 captures an FW-190 following, but its roll stops mid-motion. The ailerons had locked. The German pilot, likely Lieutenant Erich Hunk, continued straight for a heartbeat too long. Beaumont's cannon flashes in frame 49, by frame 53, the Focke-Wulf is disintegrating into flame. Post-war interrogation reports confirm the mechanical failure. The captured JG-26 war diary notes 3 aircraft lost that day, 2 due to Kontrollversagen on Sturzflug, control failure in dive. One survivor, Unteroffizier Franz Gretz, described the sensation, the stick froze. I could not move it. I saw the Englishman roll, and I could not follow. To Allied engineers, it was vindication. The Typhoon's spring-tab system, tested in sterile hangars and wind tunnels, had found its purpose in the fury of combat. At 420 miles per hour, while the Focke-Wulf stiffened, the Typhoon remained nimble, rolling with the casual precision of a fencer's wrist. Even the German technical officers saw it. An after-action memo from 3/JG-26 to RLM headquarters reads, "Enemy aircraft exhibit abnormal roll agility in dives above 600 km per hour. Our control system reaches mechanical limit. Recommend re-examination of balance or introduction of assist devices." No such devices would ever be fitted. Back at Manston that evening, the surviving pilots gathered around Beaumont's aircraft, its leading edges peppered with holes. The ground crew counted 4 bullet strikes and 2 cannon hits, yet the machine had brought him home. Beaumont filed his combat report with typical brevity, *2 enemy destroyed, probable third. Typhoon handling excellent in dive. No control restriction noted. To the engineers at Hawker and Farnborough, that single sentence carried more weight than any commendation. It proved that their vision, of leverage over muscle, of precision over brute force, had crossed the threshold from theory to dominance. By the end of that summer, the Luftwaffe had begun to avoid deep dives against Typhoon formations. Instead, they struck from above and broke away early, unwilling to risk the deadly stiffness that had claimed so many of their number. In one of his later letters, Beaumont wrote, "It was not courage that saved us that day, it was comprehension. They fought the air, we had learned to use it." On that July morning, over the burning rails of Abbeville, the argument between 2 philosophies of flight was settled. The Luftwaffe froze in the dive. The Typhoons rolled free. Autumn 1943. Across Europe, the sound of engines was changing. The Luftwaffe's once triumphant hum had taken on a strained tone, shortages of fuel, metal, and men transforming even flight itself into an act of exhaustion. Yet in design offices from Augsburg to Bremen, German engineers still clung to a faith in mechanical purity. Control tabs, hydraulic assist, and powered surfaces, technologies the Allies now embraced, remained compromises, dismissed as unnecessary or un-German. The reason, as post-war analyses would reveal, lay as much in ideology as in engineering. The Reichsluftfahrtministerium, RLM, valued precision craftsmanship above all else. Aircraft were to be extensions of the pilot's strength, not replacements for it. The belief was cultural: man should dominate machine by sheer skill. The notion that a spring or servo might help the pilot offended deeply rooted ideas of mastery. Our machines must obey the hand, stated one 1942 RLM directive, not resist it, not replace it. In contrast, Allied doctrine viewed the machine as a partner. American engineers, raised amid conveyor belts and power steering, saw human effort as something to be amplified, not glorified. The British Air Ministry's flight test branch called it ergonomic balance. At Hawker, Sidney Cam spoke plainly: if a lever makes a man stronger, it's not weakness, it's progress. This difference became decisive once combat speeds crossed 400 miles per hour. The Typhoon's spring-tab controls, first met with skepticism even among British pilots, became its salvation. Meanwhile, German aircraft, still designed for the era of human muscle, entered a domain where physics mocked pride. Captured German correspondence from the Messerschmitt Flugzeugwerk, dated November 1943, reveals frustration. A memo from test engineer Karl Bauer noted, "At high velocity, our pilots are physically overmatched. Hydraulic or spring-assisted control might be necessary." Yet the response from RLM's technical bureau was curt: such devices unnecessary if pilots trained properly for high-speed handling. By the time the Me-262 jet appeared, the contradiction was glaring. Its engines could propel it to 540 miles per hour, but its controls still relied on direct cables and rods. Pilots reported needing both hands to bank at high speed. The irony was profound: the fastest aircraft of the Reich remained captive to the strength of human muscles. British intelligence noticed. A November 1944 report by the Air Ministry's Scientific Intelligence Section concluded, German aviation philosophy remains artisan, not industrial. Reliance on physical strength has become a strategic liability. At the same time, in Britain and America, engineers were already sketching control systems that would one day become the first generation of powered flight surfaces. What began as a mechanical necessity, spring tabs, evolved into a design revolution. Yet Germany's refusal to adapt wasn't only mechanical, it was ideological. The Nazi worldview revolved around struggle, Kampf. To ease that struggle through machinery seemed dishonorable. Luftwaffe instructors warned that soft controls make soft men. The propaganda films of the period showed pilots gripping control columns like swords, the narrative of conquest tied to muscle and will. The irony was fatal. While Allied factories produced thousands of Typhoons and Mustangs with standardized parts and rationalized design, Germany clung to craftsmanship that slowed production and limited evolution. Post-war interrogations at the 1962 U.S.-Japanese Aviation History Symposium highlighted this difference. German engineer Willy Messerschmitt, reflective but unrepentant, said, "We built for the best man. You built for the average man. Perhaps that was your strength." Indeed, that was the heart of it. The Typhoon's spring tabs symbolized democracy in engineering, machines designed to make every pilot capable. The Luftwaffe's control stiffness symbolized aristocracy, machines demanding elite endurance. When the war ended, Allied investigators toured captured factories. In Augsburg, at Messerschmitt's wind tunnel, they found a file labeled Versuchsbericht über Federhilfe, experimental report on spring assistance. The tests had been done, the data conclusive. The devices worked. They had simply never been installed. By then, the war's outcome had already rendered the question moot. In the words of one Allied technical officer, they froze their ailerons for the same reason they froze their minds. The Luftwaffe's pilots had lost their wings not to lack of courage, but to an idea that strength resided in muscle rather than in mind. And so, at 400 miles per hour, ideology met physics, and broke. June 10, 1944. For days after the Allied landings in Normandy, the air above Cannes was a convulsion of vapor trails and black flak bursts. The Luftwaffe had thrown in what remained of its Jagdgeschwader to contest Allied air superiority, but the imbalance was already fatal: numbers, altitude, and technology all bent toward the invaders. Yet on that morning, one clash stood out not for its size, but for what it revealed: the physical limits of a design philosophy. At 16,000 feet, Oberfeldwebel Heinz Bremer of JG-26 banked his FW-190A8 into a climbing roll, attempting to escape a pair of Hawker Typhoons that had burst from low cloud. His aircraft was fast, durable, heavily armed, but at 420 miles per hour, its ailerons locked as if welded. He pulled with both hands. Nothing. The controls resisted, the airflow biting against them like steel tension cables. The Typhoons, rolling effortlessly into pursuit, closed the distance with eerie grace. Below them, RAF Flight Lieutenant Peter R. Child and his wingmen executed a wide barrel roll, using the spring-tab-assisted ailerons that made the Typhoon's reputation. You could feel the resistance, Child recalled years later, but the tab did the work for you. She rolled like she wanted to fight. What Bremer felt was the inverse, the sensation, as many Luftwaffe pilots later described, of being trapped inside one's own wings. At high speed, controlled deflection required enormous strength. Even the fittest pilots, accustomed to G-forces and tight turns, found themselves reduced to passengers when the airflow seized their control surfaces. Combat over Normandy was the crucible in which these mechanical truths burned themselves into memory. The Typhoon, long criticized for its thick wing and awkward silhouette, now found its ideal envelope, the low to medium altitudes where its spring-tab system provided unmatched responsiveness. RAF records from No. 609 Squadron between June 8 and July 3, 1944, document 64 confirmed engagements with FW-190s and Bf-109GS. In nearly all cases where pursuit speeds exceeded 400 miles per hour, Allied pilots reported greater control responsiveness compared to their opponents. German combat reports corroborate the imbalance. The Jagdgeschwader II War Diary, captured in August 1944, contains repeated entries: at high speed, aircraft becomes stiff, unable to roll in time. A marginal note in pencil, likely from a squadron commander, reads simply, "Enemy can still turn." These were not isolated frustrations. In post-war interrogations, several Luftwaffe survivors described encounters where their inability to roll or bank quickly meant the difference between life and death. Lieutenant Horst Petermann, interviewed by Allied officers in 1946, recounted, "You'd see the Typhoon flash under you, then it was behind you before you could move the stick. The plane was solid, but at those speeds, it fought you." For the RAF, these dogfights validated years of engineering skepticism. Before the war, many British designers had resisted spring-tab adoption, fearing they might compromise control feel. But Normandy silenced the doubters. In the speed ranges where combat increasingly occurred, between 350 and 450 miles per hour, the Typhoon's tabs transformed potential rigidity into maneuverability. Allied engineers studying wrecked German aircraft in 1944 were astonished by the persistence of unassisted control linkages. Reports from the Air Technical Intelligence Unit, Europe, note, despite numerous operational complaints, German designs continue to rely on direct manual control. No evidence of consistent aerodynamic balancing or spring-tab installation. Meanwhile, Typhoon crews used their newfound agility to devastating effect. Ground attack missions, often conducted at treetop level, demanded violent pullouts and quick rolls to evade flak. With spring tabs, the aircraft responded instantly. The Luftwaffe pilots who tried to intercept them, often flying heavier, stiffer machines, found themselves fighting the air as much as the enemy. By August, the pattern was clear. RAF kill-to-loss ratios over France climbed sharply. Of 367 Typhoon sorties logged by 2nd Tactical Air Force between June and August, the majority involved either airfield strikes or low-altitude sweeps where speed control mattered most. The official post-action summary concluded, enemy pursuit aircraft unable to match rolling responsive spring-tab aircraft at operational speeds. That summer over Normandy, physics declared its verdict. Where German control systems froze, British ones flexed. The Typhoon's designers had not just built a fighter, they had built a machine that anticipated the limits of the human body. In every dive, every evasive roll, every moment when a pilot's hands met the resistance of air, the outcome of an industrial philosophy played out in seconds. The Luftwaffe still fought bravely, but the sky itself had turned against them. By the winter of 1944, the war in Europe was already decided in the factories as much as in the skies. The RAF's Typhoons and Tempests sliced through German airspace with growing ease, their pilots no longer fighting the controls but commanding them with fingertip precision. Beneath that smoothness lay a quiet revolution, one born of metal springs and leverage, but destined to redefine flight itself. Spring tabs had begun as a workaround. They were simple mechanical helpers, using aerodynamic force to ease pilot effort at high speeds. Yet their success pointed toward a greater idea. If a small, passive surface could relieve a pilot's strain, what could a powered system achieve? The question wasn't theoretical anymore. In wind tunnels at Farnborough, Wright Field, and Langley, engineers were sketching what they called servo control, a mechanism where hydraulic or electric actuators would move flight surfaces in response to pilot input. It was a concept that seemed futuristic in 1944, but its seeds had been sown in the war's crucible. As the Typhoon's spring tabs gave pilots control where others froze, Allied design philosophy leapt forward. The mechanical linkages of 1939 were giving way to a new era, machines that no longer required brute force to master the sky. At Wright Field, Ohio, U.S. Army Air Force's engineers studied combat reports from Europe and the Pacific. Pilot fatigue, one memo read, is a tactical factor. Where control effort exceeds endurance, performance is nullified. The report recommended immediate exploration of hydraulic assist for next-generation fighters. The Lockheed P-80 Shooting Star, then in prototype stage, incorporated this lesson directly. Its controls were lightened by boosted systems inspired by the very spring-tab principle the Typhoon had proven in combat. Britain was no slower to adapt. The Hawker Tempest, Typhoon's refined successor, carried improved tabs that reduced stick loads further. Gloucester's Meteor, Britain's first operational jet, experimented with powered ailerons. Engineers at RAE Farnborough wrote, "The mechanical age of flight control has reached its limit. The next step must be powered surfaces." Germany, by contrast, still lagged behind its own innovation. Despite the Me-262's technological leap in propulsion, its controls remained primitive. Wartime testing by the Rechlin Test Center repeatedly flagged excessive pilot effort in high-speed maneuvers. A captured report dated January 1945 laments, at 800 km per hour, aircraft cannot be safely maneuvered. Pilot strength insufficient. Even as the jet age began, the Reich's most advanced aircraft remained bound by 1930s ergonomics. The Allies, meanwhile, turned their battlefield lessons into blueprints for the future. American engineers visiting British factories in 1945 were astonished by the Typhoon's control harmony. "It was a brute made graceful," wrote one observer. "Its strength lay not in horsepower but in the way it obeyed the pilot." They saw in it the first glimpse of what aviation could become when machines and men shared the load. Post-war flight test programs at Edwards Air Force Base continued this line directly. The Bell X-1, the first aircraft to break the sound barrier, used fully powered controls, descendants, conceptually, of the Typhoon's tabs. Without them, supersonic flight would have been impossible. The shock waves of transonic speed could freeze traditional surfaces as surely as the FW-190's ailerons had frozen in 1944. Thus, the humble spring tab became the hinge between eras, from the muscular age of aviation to the cerebral. At the 1962 U.S.-Japanese Aviation History Symposium, former RAF engineers reflected on this turning point. The Typhoon's spring tabs taught us that flight is not conquered by strength, said Sir Geoffrey de Havilland Jr. It's conquered by understanding the air. In that statement lay the war's final irony. The Luftwaffe's pilots had frozen not for lack of courage but because their machines refused to evolve. The Typhoon's pilots, aided by a few inches of cleverly balanced metal, discovered a truth larger than the battlefield, that mastery of the sky would henceforth belong not to the strongest men, but to the smartest machines. By war's end, the blueprint of modern flight control was written. From the piston-powered Typhoon to the hydraulic jets of the Cold War, every innovation traced a lineage back to 400 miles per hour over France, when a handful of pilots learned that resistance could be engineered away, and that freedom in the air began with the easing of a hand.